Carbon fiber, the material that forced cycling to slow itself down. By the early 2000s, nearly every professional team had switched to carbon frames, not because they looked modern, because they were lighter, stiffer, and more aerodynamic than anything that came before. But carbon fiber wasn't the first revolution. To understand how technology changed cycling, we have to go back to when racing was pure suffering. When bikes had no gears, 1903 to 1937, the first Tour de France. Riders covered nearly 2,400 kilometers over 6 brutal stages. Their bikes weighed between 14 and 18 kilograms, solid steel, no aerodynamics, no wind tunnel testing, and most importantly, no gear shifting. If a rider hit a mountain, he had to stop, dismount, remove the rear wheel, flip it, and manually adjust the chain to change the gear ratio. Imagine doing that in the Alps. This wasn't strategy, it was endurance warfare. Then, in 1937, the Tour de France finally allowed the Duranier, and cycling changed overnight. Suddenly, riders could shift gears mid-climb, they could maintain cadence, conserve energy, attack at precise moments. Mountain stages became tactical battles instead of survival tests. The derailleur didn't just make riding easier, it transformed cycling into a strategic sport.
The weight war. For decades, steel ruled cycling. It was durable, reliable, and heavy. In the 1970s and 80s, aluminum frames entered the peloton. Brands experimented with lighter materials and aggressive geometry. Aluminum was lighter than steel, but stiff, sometimes harsh over long distances. Then came carbon fiber in the late 1980s and 1990s. Carbon changed everything. Unlike metal, carbon fiber could be molded into aerodynamic shapes. Engineers could control stiffness in specific areas. Frames became lighter while staying rigid under sprint power. By the late 1990s, professional bikes were becoming dangerously light. So in 2000, the UCI introduced a minimum weight rule, 6.8 kilograms. Not maximum, minimum. Modern race bikes can actually weigh less than that. Teams sometimes add weight to reach the legal limit. For the first time in cycling history, innovation had outpaced regulation. The aerodynamic revolution, 1990s to present. At speeds above 30 kilometers per hour, 70 to 80% of resistance comes from air drag. That means fighting wind matters more than fighting gravity on flat terrain. In the 1990s, professional teams began using wind tunnels, the same facilities used for aerospace testing. Frame tubes became airfoil-shaped, cables were routed internally, wheels became deep-section carbon rims designed to slice through air. Time trial bikes started looking less like bicycles and more like machines from the future. An aerodynamic helmet alone can save up to a minute in a long time trial. Over a 3-week Tour de France, that difference can decide the yellow jersey. But aerodynamics created controversy.
The position that was too fast. In the mid-1990s, extreme riding positions appeared in time trials. Riders stretched their arms forward, flattening their bodies to reduce drag. It worked. Time gaps widened, speeds increased dramatically. The governing body reacted quickly. The UCI introduced strict regulations on saddle setback, handlebar extension length, frame geometry, rider positioning. Why? Because engineering was starting to dominate athletic ability. Cycling had to protect the human element. Innovation was allowed, but controlled. Clipless pedals and efficiency. Before the 1980s, cyclists used toe straps. They secured the foot but limited power transfer. Clipless pedals changed pedaling mechanics. Now riders could push down and pull up, creating a smoother and more efficient pedal stroke. In sprint finishes, that extra efficiency matters. Over a 200-kilometer stage, it compounds. Marginal gains became measurable, and cycling entered a new era, optimization. Disc brakes, control versus tradition. For decades, road bikes used rim brakes. They were simple and lightweight, but in wet conditions or long mountain descents, braking performance could fade. Disc brakes entered professional road racing around 2016. They offered stronger braking power, better heat management, improved control in rain. Traditionalists resisted, but over time, the peloton adopted. Today, nearly every pro team rides disc brakes. Innovation often faces resistance before acceptance.
Electronic shifting. Mechanical cables stretch, wear down, fail. Electronic shifting systems removed those variables. Instant, precise gear changes, no cable friction, consistent performance. In high-pressure moments, sprint finishes, steep climbs, precise shifting can determine victory. The modern bike is no longer purely mechanical, it's digital. The data revolution, power meters. Perhaps the most influential innovation isn't visible at all. Power meters measure exact watt output in real time. Before power meters, riders trained by feel. Now they train by numbers, functional threshold power, sprint peak watts, sustainable effort zones. Race pacing became mathematical, training became scientific. Cyclists evolved into performance analysts. Marginal gains and regulation. As innovation accelerated, regulation followed. The UCI introduced rules covering minimum bike weight, frame aspect ratios, saddle positioning, handlebar dimensions, equipment standards. Even sock height is regulated. Because in elite cycling, tiny advantages become decisive. The sport constantly balances three forces: speed, safety, fairness. What comes next? Today's professional bikes are carbon fiber optimized, wind tunnel tested, electronically shifted, data integrated, strictly regulated. But innovation never stops. 3D printed components, integrated aero systems, advanced materials, AI-based training analytics. The next breakthrough may already exist, and when it arrives, the rulebook may need to change again, because cycling has never been just rider versus rider. It has always been rider, engineer, and regulation, and that battle is far from over.